Let's get started. Well, welcome to our talk. Generative AI is new and exciting, but conversation design principles are forever. Yeah, today we are Alessia. Alessia, you want to introduce yourself?
Of course, yes. So, hi everyone. It's great to be here. My name is Alessia, and I work for Google Cloud. I'm a cloud consultant in the Google Cloud Professional Services team. And with me today, we have
Xavi. I'm a Google Cloud Champion Innovator and also a Google Developer Expert in Machine Learning. I love Dialogflow and Conversational AI. So yeah, feel free to follow us in all our social media. And I'm working as a head of cloud infrastructure at VoiceFlow. Um, this is the content for today's session. Today we will start by talking a bit about divergence and convergence in the context of communication. We will then compare large language models and virtual agents. Afterwards, we will review together some good practices and pitfalls to keep in mind when designing a conversation and how we can mix up deterministic and generative features in Vertex AI conversation and also Dialogflow CX. Lastly, we will demo a multimodal conversation with a virtual agent that combines deterministic intent-based agent design techniques with generative AI features. So let's get started. We would like to start this session by talking a bit about like divergence and convergence in the context of communication, as we said, and explain the difference between open-ended conversation that helps users learn versus goal-oriented conversation that help users solve a specific problem. And we will keep this in mind as it relates to designing virtual agents in Vertex AI Conversation and Dialogflow CX. So imagine a conversation where we delegate the whole user agent dialogue to a large language model. For example, using Vertex AI, Gemini API instead of Dialogflow CX. It becomes an open-ended chat, as you can see there. That always seems to diverge instead of converging towards the problem's resolution. If you are actually trying to solve a problem, like reporting a property damage, what seems like creativity and open-ended possibilities might turn into a frustrating user experience. On the other hand, if we were to only use deterministic intent-based design in our Dialogflow-based chatbot, it might get the job done, but users would feel like they were working with an impersonal robot rather than a helpful assistant. We will break the two concepts of generative text and deterministic agent design into two components: creative, expressive conversations, what is the same as divergence, and focused problem solving conversations, or also known as convergence. So let's get started with convergent thinking. Convergent thinking focuses on reaching one well-defined solution to a problem. This type of thinking is best suited for tasks that involve logic as opposed to creativity, such as solving a problem where you know there are no other possible solutions. In this vignette, as you can see, these two people are discussing about going out for dinner, and then lastly agree on cooking at home. Due to the ability to steer conversations and make transactions, virtual agents are quite good at this part of the conversation. In the other hand, divergent thinking is exactly the opposite of convergent thinking and involves more creativity. There are certainly advantages related to divergent thinking. It can help you identify new opportunities and find creative ways to solve problems. However, as we can see in the vignette, divergent thinking might take these two people far away from reaching a common goal. Due to their generative nature, large language models are quite good at this part of the conversation. So, when we are designing conversations with users, we want to ensure that we are divergent when it comes to options and possibilities, and convergent when we are trying to help them solve a problem or make transactions. In the rest of this session, we work through specific examples of blending generative languages from the Vertex AI Gemini API with deterministic agent design in Vertex AI Conversation and Dialogflow CX. So let's see this example. In this example, what happens when we design a virtual agent to be convergent and only help users with a specific goal. Um, the user's goal is in this example is to book a live board for his family. Notice how the agent is not too prescriptive. However, thanks to large language model, it does handle an unexpected destination as well as the user intent to take a scuba course. It resets the expectations about what is and what isn't possible and steer the conversation back to the successful path, which is really important. It would be extremely hard and almost impossible to design an agent to handle the myriad of unexpected user inputs. That's when generative AI comes into play. Now let's put our best practice into action and design a blend of deterministic goal-oriented conversations. And we will see how the agent is designed to switch to a generative and large language model-based approach when it's appropriate. Once the question, for instance, in this example is answered or the instruction is over, the agent returns to helping the user with their primary goal. So now that we have pretty much clear what is convergence versus divergence and how we should use that in our agents. Let's talk about generative AI in conversations. Alessia, can you explain to us what is generative AI in conversations? How can we leverage that?
I'd love to do that. But before that, we actually need to um, uh, give a little bit of an introduction about large language models and the differences between large language models and virtual agents. Okay, so what is a large language model? It is a type of a model. It is a type of a language model which is able to generate and understand. Which is able to generate code or text based on natural language. And how does it do that? Well, do that, it acquired this ability by using a massive amount of data to learn billions and billions of parameters. And generative AI is, in fact, the application of a large language model to generate text based on user input. And it does this by acting as a word probability machine on the corpus of data that it was trained on. And this is here we want to sort of like explain reiterate the concept that Xavier already explained once again about the main differences between LLMs on the left-hand side and virtual agents on the right-hand side, because we feel we work every day with developers and we feel that somehow we're getting a little bit confused about the boundaries. So we really want to draw a line on the sand. So a large language model, as Xavi mentioned before, like users can prompt with an LLM in a divergent way across a range of topics. It really feels like we are talking to a buddy sometimes. The issue is because it's undeterministic and very often training happened a while ago, the responses might not be always accurate and grounded to the context, to the knowledge base that we want, as opposed to virtual agents that, as Xavi mentioned before, can really guide users to solve a specific issue, like reporting a graffiti damage, or help them decide to make a purchase or recommendation. So it's definitely a guided conversation that we can overlook as developers, that we can design. In Google Cloud, when it comes down to conversational AI, we've got a large spectrum of tools and services, from the more deterministic ones, the most deterministic ones on the left-hand side, and Dialogflow CX. If you are familiar with that, we're talking about a platform that allows you to build and design agents using the building blocks of NLU, so intents and training phrases and entities and fulfillment, So on the right hand side of the spectrum, we've got the most generative ones, like chatting with the Vertex AI Gemini API on a large spectrum of topics, as well as visual agents actually created using natural language instructions and structured data in the form of playbooks. In between, we've got different levels of generative features. On the left-hand side, we've got data store agents, and I'm going to dive deep into this one in a second. As well as generative fallback that we saw in action before in the conversation between the user and the agent about booking a liveaboard. This one is great to steer the conversation back on track if the user tries to go a little bit off the script. And then generators that when they are plugged in at any point in the dialogue that make native calls to an LLM for a variety of tasks. Okay, so let's dive a little bit into one of these features that we recently introduced into Dialogflow CX and Vertex AI Conversation. Okay, so what is a data store agent? A data store agent is an agent which is able to have conversations and answer frequently asked questions. The answers come from a knowledge base that we've provided as a website or a list of unstructured documents. Could be Google Cloud Storage or BigQuery. So you provide the knowledge base, and Dialog and Visual and Vertex AI Conversation builds this agent for you, which is powered by LLMs. So when the user asks the question like, can you help me choose the most suitable mobile plan? What happens behind the scenes is the Vertex AI search will look for a search for relevant documents based on the context on the conversation, based on the question itself. So if it finds the documents, then the documents itself, as in obviously a representation, so as a vector database, the information that's been retrieved together with some parameters that we can inject into the prompt. Of course, the prompt itself, when I say parameters, I'm actually talking about specific information that we've collected during the conversation itself. So information that can augment somehow the response. So it all gets sent to an LLM, which responds knowing. So the responses are grounded to the knowledge base, but have got their humanity that otherwise we wouldn't be able to do with a simple FAQ chatbot that we are used to. So the response is put in a coherent, in a consistent way. And it's displayed back to the user. We can also include links there, obviously take the user back straight to the knowledge base. So this is how we've implemented retrieval augmented generation, which is a technique that allows generative AI to return better, more grounded, accurate, timeless answers by tapping into additional data resources without obviously retraining. That's exactly a definition of what actually a RAG system does. Now, let's see how we have plugged these features into how they somehow play in the traditional life cycle of a page in Dialogflow CX. So when the user input reaches Dialogflow, the agent will first do step number one, will first fill in any parameters, if there are any parameters at that point in the page. So it's going to fill those buckets, and those are actually the entities that we want to extract from the end user input. So far nothing different. And then, of course, if there is an intent in scope in that page, so if there is an intent that matches the user input, it will fulfill that intent in a traditional way via a webhooker calling an API, or that's where we can plug a generator, which, as we said, is going to make an LLM call, passing a prompt that's been defined by the user together with the conversation, the last user utterance, and some parameters. What happens if Dialogflow didn't find any intent in their page or in the flow for that specific user utterance? We'll fall back in a way to the data store agent, because very likely that question can actually be answered by the knowledge base. There is a chance actually that search didn't retrieve any documents, and therefore that's actually when a no match is raised. In case of a no match for a parameter because the user did not provide a parameter that met with the expected definition of the entity, or just because it actually said something unexpected, as we saw before, or the phone is ringing, sorry, I need to talk, I need to take this call, or things like that. At that point in time, what happens is we fall back to generative form.
And reset expectations about what the agent can or can. So, as I mentioned before, it's really, really important now
that we've added these generative capabilities, that we really, really keep in mind what the fundamental conversation design principles are to preserve the human factor. And that's what we want to do in this slide. So we reviewed together, with Xavi, we review some of these best practices and pitfalls to keep in mind. Well, one is what a data store agent wants to do. It wants to generate up-to-date and grounded responses. How can we do that? Well, we plug a knowledge base, which is represented as a vector database or a graph database or document stores. So this way, we're able to overcome the limitation of an LLM that's been trained a while ago to generate accurate and grounded and timeless responses. As Shabin mentioned before, it's important to understand that the LLMs provide non-deterministic responses, and they obviously tend to diverge. Why? Well, because obviously it's a fully generative conversation that it might go as a little bit, as we said before, off the guardrail. So it's important to keep in mind that LLMs are definitely great to when it comes to options and possibilities, but we want to converge when we want to help the user solve a problem. And then the third one, if we remember the 80-20 rule or Pareto principle, and we also keep in mind that we want to be cooperative and help users solve a problem, we can't obviously expect that we forecast and we design the agent for all the detours and unexpected conversational parts. And that's when for LLMs really come into play. So to somehow cover those common detours when an unpolished answer like sorry, I can't really help you, are not good enough. Chubby, do you want to walk us through the other three?
Yeah, sure. The next one that I wanna mention is basically to mix deterministic design capabilities and creative genetic features. Basically to cover a wide range of user journeys that involve information retrieval, troubleshooting, and transactions. Basically to help the user to go through the happy path and and to reach their goal. That's really, really important. The second one is, of course, inject generative content, because we can, or the users can feel that the experience is more close to, like to the one that you can have with a human. Because as you know, like the people are really tired to interact with just chatbots or just like agents that are like robots. So that's why the generative AI in communication, in conversations, is so important. And then the last one, I think that's also really really important, is to be also aware of the potential security threats related to large language model based applications that process very sensitive user input, since they are subject to prompt injection. You will need to know which like technology are you are using, if you are using a public instance, if you are using a private instance, and how is that data, the data that you are sending to LLM, how is that being processed. So these are like the six main guidelines that we wanted to showcase or to clarify today. And Alessia, I think she is gonna go over the Goodbye Graffiti, the demo that we promised that we had.
Yeah, it's a demo that showcases a multi-model application. It's an application that combines visual elements with obviously text, so speech to text translated real time. But I don't want to spoil it too much, so let's actually go straight into the demo.
Hi there, I'm Mel, the helpful virtual agent for the residents of the City of Mel. I can assist with a variety of matters across the city, including reporting an issue, paying a parking fine, booking a hard waste request, or just letting you know what's on in Mel. How can I help you today?
Hi, I need to report a damage to my property.
I am very sorry to hear about the damage to the property. I need to ask you for a few details so we can get started on cleaning it up. First, what's your address?
Give me 1 second.
Sure, take your time.
Thanks. The exact address is 38 Knott Street, Port Melbourne, Australia.
Thanks, I have collected the final address. Is that correct?
Yes, that's correct.
What has been vandalized? Can you describe the damage? Thank you for your report. We have received your report about the scratched and painted garage door at 38 Knott Street, Port Melbourne, Vic 3207, Australia. We will investigate the matter and take appropriate action.
Thank you.
In case we need to follow up on this case, we will call you on this number. For now, thank you and have a great day.
Okay, so just a little bit of a wrap up of what we actually seen. So we've seen two of these generative features, generators and generative fallback, working in a way sort of like in tandem. You see that the conversation went on screen for a second, and the agent took it back on track. Multimodal, we combine visual elements with voice. This is particularly useful in crowded places where sometimes, noise has an impact on the accuracy of the translation. And last but not least, we also integrated this agent with the Google Maps API to look up the latitude and longitude of the location. With that said, Xavi, do you want to cover a little bit the resources for our folks there online?
Yeah, for sure. So there you have here all the resources that we have used and for this presentation, and that is going to be really useful for you for the future. There you can find the Goodbye Graffiti agent, that web app that we just showcased. That is there, and that is the QR code goes to that web app as well. Then you have the conversation design guide. It's really worth it to read it, because you will learn a lot of like conversation design practices, and like best practices, and how to create agents with like complex conversations. Regarding generative AI, you can have the next resource to talk about to search for use cases in generative AI. And then there's the Alessia's Medium, where you can find like articles related to conversational AI, and specifically there's one article that covers all these presentation, and that's it's a pretty good article. So please make sure that you check it out. And with that being said, I think that's it. Thank you, everyone, for coming. If there
I'm going to
are,
stick around a little bit in case there are any questions.
yeah,
But like I see we're a little bit over time, but I'll probably leave this slide for those who are taking notes. And if you have any questions, then we're here.
yeah, we are happy to answer all your questions.
Just give a minute or so. Okay. Thank you. And of course, there are lots of other learning resources. That one of those links. Let me have a look at that slide. It's the top one. It will actually that page will actually take you to the source code, to the GitHub repo, where you can download the source code and actually install it by yourself. We had to fly a little bit and go. That's where we can definitely check it for you. I'm actually doing it right now as we speak. It does work for me. Yeah, I'm not sure. I've just copied and pasted the URL in the browser and it works for me.
It works for me.
Yeah, I'm not sure. And it's a public, and of course it's a public page, it's a public web app. Cool. So I hope that you enjoyed this talk. In case you want to reach out, we shared at the beginning of the talk our coordinates. We'll be more than happy to hear from you, to hear your feedback, and to connect, of course.